Hello, today I want to start exercise 4.2 of NCERT, in which I am going to solve some questions using properties of determinant. As in previous lecture, we have already discussed about the properties of determinant. Now by using those properties only, we are going to solve these questions. So first question, let us see what it is saying. It is saying that using the properties of determinant and without expanding. For reference, I have written here in right hand side corner these properties. So let's start. So what will be the process? Process is that we have to make LHS equal to RHS. So LHS is 0, RHS is 0. So now we have to make LHS 0. So which property we are going to use? We are going to use this property which says Ri is equals to Rj, then determinant will be 0. It means that if any row or any column of a determinant is equal, then that determinant is 0. So now let's take, first we will write what will be the step. The step will be to prove LHS equal to RHS equal to 0. So as we see that here RHS is 0, so we have to do LHS equals to 0. So let's start. So first step, step 1, we can write like this if we are writing an exam. So first step will be, what we have to see here, that determinant we will expand this step. Determinant we will write x, y, z, a, b, c, and x, y, z. This we can write this. We will open this. We can write this x plus a as a 2 determinant, as we have seen the property in last lecture, that we can expand these determinant like this. So now this can be written as x, y, z, a, b, c, and here what remained, x, y, z we have written in first determinant, so here it is remained a, b, c. So now we see that here column 1 is equals to column 2, and here column 3, here column 2 is equals to column 3. So this is 0 and this is also 0. So now what is this? 0 plus 0 equals to 0. Hence proved. Now let's go to the next question. This question, in this we will take that we will use this property first we will expand using this property. We will, what we are going to do, we are adding all the rows, and so here also LHS should be equal to RHS. That is, what is RHS? RHS is 0, so we have to make LHS 0. So let's start with LHS. So for LHS we have to make it 0. So now what will be the first step? Here, in what steps we are doing, we have to write what is the reason behind that doing that step. So first step here will be, we are going to replace, here we will write first step, R1 is replaced with R1 plus R2 plus R3. So we are writing here A minus B plus B minus C plus C minus A. Now next column will become A minus B plus B minus C plus C minus A. Now column 3 will become C minus A plus B minus C plus A minus B. Now other rows R2 and R3 will remain same as it is, B minus C, C minus A and A minus B, and third row also will be same, C minus A minus B and B minus C. Now we see here these all terms get cancelled out, C A and here also B C A, here also A B C. So here the determinant will become like this, first row will become whole will become 0. So now as we know that if any row or any column of a determinant is 0, then the value of that determinant is 0. So the determinants will write that same like that, A minus B, and last is C minus A minus B and B minus C. So this determinant will become 0, hence proved. Now come to the next question, question number 3 of exercise 4.2. So in this question, here also what it is saying, we have to, by using the property of determinant, we have to use the property of determinant, and without expanding we have to prove that this determinant is equal to 0. So here also what we are going to do, we will take LHS. So first step, you have to use your mind what you can do so that any row or any column should be equal to another. So how we can write this? We can, if you see, you can write this as 63 plus 2 and 72 plus 3, and this one you can write 81 plus 5. So you can see that if we expand these two, this determinant, we see that this can be written as 2, 3, 5, 7, 8, 9, then 63, 72 and 81. Now again we can write one more determinant, 2, 3, 5, 7, 8, 9 and 2, 3, 5. So what we have seen here, we see that these two columns are, column 1 is equals to column 3. So this determinant will become 0 if we name it as determinant 1 and determinant 2. So determinant 2 has become 0. Now we have to expand determinant 1 only. So determinant 1 will be equal to, we can write it like this, 2, 7. First we will write first column, 2, 3, 5, 7, 8, 9. Now you see that all these third column, all the terms are the multiplication of, sum of the multiplication of 9. So what is this? 9 into 7 is 63. Okay. 9 into 8 is 72 and 9 into 9 is 81. From this you can take common 9 because it is common in column 3. So 2, 3, 5, 7, 8, 9 and this is 7, 8, 9. Now what you see that column 2 is equals to column 3. So this determinant 2 is equals to 0. So as we see that determinant is equals to determinant 1 plus determinant 2 is equals to 0, hence proved. Now come to the next question, question number 4. So question number 4, here also what it is saying, using the properties of determinant and without expanding. So we will take LHS, and LHS, what we will do, we'll write it like that. First step, what we are going to do, we will write here. So if you add column 2 should be replaced with column 3 should be replaced with column 2 plus column 3. So first column will be written as it is, second column will be written as it is, and third column, what it will be, AB plus BC plus AC. Second column, AB plus BC plus AC. Third column, AB plus BC plus AC. So now what we will do, we will take common from here, AB plus BC plus AC. Now the determinant will become like this. Column 1 will be 1 1 1, BC, CA, AB. Now third column will be 1 1 1. So now we see that here column 1 is equals to column 3. So by using the property, if any two column is equal, then that determinant is equals to 0. So here also we have proved using properties without expanding the determinant. Now next comes the question number 5. Question number 5 is bitter lengthy. Here we have to prove that LHS is equals to RHS. As we see that we have a bigger side LHS, so we will take first LHS and reduce it to the RHS. Now for that, what we are going to do, first we are going to apply first step. In first step we are going to apply here LHS. First step is R1 should be replaced with R1 plus R2 plus R3. Now if we do this, it will be like this. First determinant, what it will become? First we will write R1 row 1 plus row 2 plus row 3. So here every term is 2 times, so we will write A plus B plus C. Directly we are writing because it is understood. Next step, P plus Q plus R. Third will become 2 times of X plus Y plus Z. This is first step. And both other rows will be written as it is, R plus P, Z plus X. Here it will be A plus B plus B, P plus Q, and X plus Y. Now next step we will expand this. This we can expand this and we will take 2 common from here. So if we take 2 common from here and we expand it in 2 determinants. So first we will write A plus B, P plus Q, and X plus Y. third row will be C, R, Z. Next we will write other terms as it is. What will be that? Here we will write, otherwise we will not understand. C plus A, R plus P, Z plus X, A plus B, P plus Q, and X plus Y. So from here we see that R1 and R3, here R1, in this we see here that row 1 is equals to row 3. So this determinant will be 0. So it is excluded. So now we have left with this one only. What it is? C plus A, R plus P, Z plus X, A plus B, P plus Q, and X plus Y. Now this determinant has become 0. This whole determinant has become 0. So it is excluded. Now in another step we will apply the two conditions. We'll write here that we'll write two conditions that R2 one second, this we will write here first. What we are going to do next, we will write here R2 is replaced with R2 minus R1 and R3 is replaced with R3 minus R2. Okay, so what we will get? We write here, we get first row will be as it is, C, R, Z. 2 is here, so 2 will be written here as it is, and R2 minus R1. So R2 minus R1, R2 minus R1. So this will be A, and this R2 minus R1, R get cancel out. So this will be P, and this Z get cancelled. Here will be X. Now last column will be R3 minus R2. So A, R3 minus R3 minus R2. What we have got in this, no, this step, this will get subtracted with this. Now this R2, new R2 will be get subtracted with R3. So we will left with B, and PP get cancel out. So we will get left with Q, and last what we are Z, X has get cancelled. So we are left with Y. Now this is the final. We have got the answer. Now just we have to interchange. So what we are going to do after that, we will interchange R1 with R2 and R2 with R3. So we know that if we interchange any row or column, then it gives a negative sign. So this one negative sign and this one negative sign. So both negative signs will become, in the final step, it will become positive. So finally we will get the answer, that is 2 A P X PX and B Q Y and C R Z. This we will get. So hence this is also proved. Now next question number 6. We'll solve question number 6. Here we have to use the properties of determinant, and in last step only we have to expand somewhere, but in other steps we will solve as it is. So in this question what we are going to do, question number 6. Okay, so in this we are taking LHS. LHS should be equal to 0 because RHS is 0. So in this we will write first step what we are going to do. LHS, we are going to do what steps we are going to follow. R1 should be replaced with C R1, and R2 is replaced with BR2, and R3 is replaced with AR3. Now we will do all this step in a single. So if we are multiplying any row with that, then we know that that will also get divided by the whole. So we will take all that elements outside A, B, C. Now first we are going to multiply R1 with CR1. So it will be A0, AC and minus BC. Next R2 will be minus AB, 0 and minus BC. Last step what we will do, last row AB, AC and this will be 0. After this what we are going to do, we will in next step we are going to replace R2 with R2 plus R3. So it will become 1 upon ABC will be here only, and R2 plus R3. So this row will, so first row will be as it is, 0 AC minus BC. This row R2 is replaced, so this will become 0. Here it will come AC. Here it will be as it is minus BC. Last step is, last row will be, row 3 will be written as it is, AC and 0. So what we see here, that this row 1 and this row 2 both are equal, that R1 is equals to R2. So by this property we know that if any row is equals to any column, then that determinant is 0. So this is also 0. So we have proved that LHS is 0, since we have proved. Now comes question number 7. In this question what we have to do, in this question we are using we have to use properties of determinant, and then we have to prove it with this RHS. So what is RHS? RHS is 4A square B square C square. So let's start with LHS proof. First step what we are going to do, we will take A common from A, B, C, common from each row. So here we write common A, B, C from each row. So from first row we are taking out A, so it will become minus A, B and C. Second row we are taking B, so it will become A, minus B and C. From third, B common we have to write here. Now third row we are taking C common, so it will remain A, B and minus C. Now first step. And second step, what will again take common A, common A, B and C from each column. Now, so it will become, so here we have forgotten to write C. So now if we take column A, B, C, from it will become A square, B square, C square. Now we are left with minus 1, 1, 1, 1, minus 1, 1. I should write this clearly, otherwise it will be mistaken. 1, 1, minus 1. Okay. Now next step, what we are going to do? Now third step, we write here, we will solve, we will replace C2 with C2 plus C1 and C3 with C3 plus C1. So it will become A square, B square, C square, and if we replace first column, first row will be as it is, first column will be as it is, and second column will be C2 plus C1, so it will be 0, and then we are adding to 0, then it will be here 2. Now third column, first we will add C1 plus 0, this will be 2 and this is 0. Now if you expand it along this, so what it is, it will be A square, B square, C square, and expanding it along minus 1, so will this will come, so it will 0 minus 4. So finally what we will get, minus minus get positive, so 4 A square, B square, C square. So we have proved it to the right hand side, so hence proved. Thank you. For any queries you can visit our website Samarth Academy.